Alright, starting on problem 24, we are going to solve the equation e to the negative 0.08t equals 10. Now remember that when we talk about e, we are talking about a special number, kind of like pi, and you have an e button on your calculator. Now again here with a multiple choice test, maybe your best strategy is to guess and check, but if you were going to solve this, what you would want to do is take the log of both sides. Now it doesn't matter what log you do, whether it's just regular log base 10 or it's natural log, but in either case, you would take the log of both sides. It will save you a step if you take the natural log, so that's what I'm going to do. So natural log of e to the negative 0.08t equals natural log of 10. And you can see that the original problem is still there. But see, the advantage of taking the log of both sides is that it lets us take the exponent and move it out front. That is one of the properties of logs. So after I do that, you'll see that out in front is negative 0.08t. Still have the natural log of e equals the natural log of 10, and I have no more exponent. Now the reason that the reason taking the natural log saves me a step is that the natural log of e is just 1. In other words, it cancels out. Now, that's kind of convenient. Saves me from having to divide both sides by the natural log of e, because the natural log of e is 1. E to the first power is e. So what that leaves me is with the equation negative 0.08t equals natural log of 10. So all I have to do is to get t by itself, divide by negative 0.08, and those cancel. Divide by negative 0.08, and then I'm going to use my calculator at this point. Natural log of 10 divided by negative 0.08, and the t variable is approximately negative 28.78. Alright, now number 25 is also an equation, but it already has a log in it. And the easiest way to solve one like this is to just change forms. See, this is in logarithmic form, but in exponential form, it means that base 5 to the 11th power, 5 to the 11th, equals 2x plus 7. And if you've forgotten how that all works, remember, let me do a different problem here. You know, if log base 10 of 100 is 2, because 10 squared equals 100. So it's the same idea here. 5 to the 11th equals 2x plus 7. And at this point, this is a very easy solve. The number gets pretty large because 5 to the 11th power is 488282125, very big number, equals 2x plus 7. So we're just going to minus 7 from both sides, minus 7, and then we'll have to end up dividing that answer by 2, because 2x will equal that. So divide both sides by 2, and your final answer, 24414,059. Very large number. Don't care what the answer is, more interested in your understanding of how to solve it. Okay, 26 gets into the same idea as 24. We have a model where we start with 2,000 bacteria, and the bacteria double each hour, and you'll notice in our model, you'll see we have a growth rate of 2 there. So how long will it take the culture to grow to 70,000? So they're giving us the number of bacteria, 70,000. And we know that it grows. We started with 2,000 and we double every hour. So we need to figure out how many hours it takes to get there. So again, you could guess and check, but if you want to solve this algebraically, it's pretty quick. We'll divide both sides by 2,000, and 70,000 divided by 2,000 is simply 35. So 35 equals 2 to the t. And we'll just take the log of both sides. So we'll do the log of the 35 and the log of 2 to the t, keeping in mind that I am allowed to move this t once I take the log out front, goes right down there. And so to get t by itself, it's really easy. T times the log of 2, I'm just going to divide by log of 2, divide by log of 2. So those cancel, and t will be, I'll just have to use my calculator, log of 35 divided by log of 2. And t is going to be approximately 5.13, like such. Alright, moving on. Which function matches the graph? Now, here's the thing. There's all kinds of fancy rules with these are rational expressions. You can see that they have like asymptotes here and here. There's all kinds of fancy ways to memorize what that graph looks like, but to be perfectly honest with you, I would put these in my calculator and match the graph. You know, this is really just y equals, y equals, y equals, y equals. So just go ahead and match them, type them into your calculator, and see which one is the correct one. And when I do that and I hit the graph button, you will find out that it is letter C. Right here, x plus 1 over x plus 4. Alright, moving on to number 28. These are all going to be about rational expressions. We just shifted chapters here. And we're going to be doing some canceling. But the key to canceling is we have to be able to factor. Looking at this expression, I'm not really sure exactly here what's going to cancel. The only way I'm going to know what they have in common is if I factor them out. So if I factor the bottom, I believe you should get x plus 5 and x plus 2. And on the top, if you factor, I believe you will get x plus 5 and x minus 3. And I'll leave it to you to verify the factoring. We've been doing that for a while. But what you'll notice is that both the top and the bottom we can now see have an x plus 5. And x plus 5 over x plus 5 is just 1. So we end up with x minus 3 over x plus 2. Like such. Number 29 is similar, except we're going to do a multiply here. And there's a couple of ways we can play this. We can actually, because it's multiply, you can cancel right now if you want to. But I'm going to multiply it together first. So when I multiply the tops, I'm going to get 7 x cubed, y to the 7th, and z. Now, if it looks like I just put them together, I did just put them together. And the reason I did that is simply because I don't know how to multiply x's and y's together, so I have to keep them separate. And on the bottom, 5x, y, z. So now I'm going to look to do some canceling. I want to start by looking at the numbers 7 and 5, and 7 and 5 don't have anything in common, so I don't know what else is going to be in my answer, but 7 and 5 is going to be there. Now if I look at my x's, because I can only cancel x's with x's, it looks like this bottom one is going to cancel with 1 up here, leaving me with just x squared on the top. If I look at my y's, I've got 7 on top, 1 on the bottom. 1 will cancel. That'll leave me with 6. And it looks here that I have a z on top and a z on the bottom. Those will cancel, and that'll be my final answer. Number 30 is the same idea, but to really see what's going to cancel, I'm going to have to factor, right? There were in 29, there were absolutely no adds and subtracts. It was all multiplies. But here I've got some adds and subtracts, and to really see what's going to cancel, I have to factor. This guy is a difference of 2 squares, x minus 4, x plus 4. This guy down here has a common term, 2. I can pull a 2 out of both parts, x minus 4. And now I can, again, just like before, if at this point you want to cancel the x minus 4s, you can. I'm going to show it all together. So in my numerator, I've got x, comes from right here, then the x minus 4 and the x plus 4. And in the denominator, 2, x minus 4, and x plus 5. The order you write these terms in doesn't really matter. I wrote it so that the single things were out front. It doesn't have to be that way, but it looks a little weird if you don't. The only thing that's going to cancel here is the x minus 4s. And so my final answer will be, I'm going to write it up above here, will be x plus 4 over 2 x plus 5. And you don't need to distribute or put that together in any way. That's as simple as it needs to be. Okay. So this one we're going to divide the expression. Now dividing and multiplying are the same thing, except when you divide, you multiply by the reciprocal. So we're going to think of that as x plus 7 over 1, and this problem is really x squared minus 49 over x plus 7 times, notice I'm changing it from divide to times, 1 over x plus 7. Okay, like such. Now, this, again, to see what's going to cancel, I have to factor. There's only one thing that's going to factor here, and I didn't leave myself much room, but this guy up here, it's going to factor to x plus 7, x minus 7. It's a difference of two squares, and that's going to cancel with one of, and it doesn't matter which one of the x plus 7s on the bottom. So you're going to end up with, on the top, just x minus 7, and we don't care about the 1. So x minus 7, and on the bottom, x plus 7. So just like the two previous problems, except divide, you flip and change it to multiply. Alright, so after multiply and divide, we'll look at some add and subtract problems. Number 32, this one is an example of adding and subtracting when you do have like denominators. So doing that's really, really easy. My answer is going to be over the common denominator 18x. And I simply have to add the numerators together, and that's just a matter of combining like terms. Negative 3x plus negative x is negative 4x, and 4 plus negative 4 is 0. So I don't even need to write that over there. Now at this point I'm just going to look and see if I can simplify anything. It looks like the x's are going to cancel out, and negative 4 over 18, I think I can pull a 2 out of that. So negative 2/9 is what that guy should simplify to. A lot of times adds and subtracts won't simplify. This one did. Now in 33, what you will notice is that these denominators are not the same. This guy has an x plus 5, this guy has an x minus 5. Those are two totally different things. So in order to get the denominators the same, we're going to have to give the denominators what they don't have. This one needs an x plus 5. And whatever we do to the bottom, we have to do to the top. And this guy over here needs an x minus 5. And then on the top as well. So what we're going to end up with, notice the denominators are the same now. We are going to end up with an answer over x minus 5, x plus 5. But we've got a little bit of work to do to put the numerators together. So you'll notice that to put those together, I might have to do a little bit of distribute property. So just looking at the 6 and x minus 5, I'm going to have 6x minus 30, then plus, and then this guy, 5x plus 25. Again, I'm applying the distributive property to multiply that through. To finish this guy up, what I'm going to do is just combine my like terms. So I see a like term here and here. 6x and 5x is 11x. Negative 30 and positive 25 is negative 5. And just over my common denominator, x minus 5, x plus 5. And there it is.